I'd like to talk to you today about tree diagrams. We'll be taking real-world scenarios that involve making choices and determining the probabilities of events using tree diagrams. So we're going to take a maze and draw a tree diagram to determine the possibilities of winning a pumpkin. So the first thing we got to do when we start, we have a choice to make. We have three possible options. That is the upper, the middle, or the lower path. If we take the upper path right here, there's a choice to make. And that choice will end up with either us having pumpkins or no pumpkins. If we take the middle path, well, that middle path has no choice. So if we take the middle path, we'll get a pumpkin. And then the lower path, if we take this lower path, there's another choice to be made. That choice will end up with pumpkins or no pumpkins. So here's our tree diagram. To determine these probabilities, you'll notice that the first choice has a 1/3 chance of making the upper path, lower path, or middle path choice. And then the second level, you'll notice that there's two choices, so it's a 1/2. So to determine probabilities in a tree diagram, we multiply down the tree. So the probability of getting a pumpkin taking the lower path is 1/3 times 1/2 is 1/6. The probability of not getting a pumpkin taking the lower path is 1/3 times 1/2. That is also 1/6. So we can determine probabilities from a tree diagram by multiplying the possibilities or multiplying the probabilities going down the tree. So now we're going to look at a menu. We go to a menu where they make sandwiches, and let's just say it's a basic menu like this. There are three choices, so that means there will be three sections of our tree diagram. So the first section we have here, we have to choose the bread, the white or wheat bread. And then we have to make the choice about ham, turkey, or beef. And that choice is reflected over here as well, because if we choose wheat bread, we still have the same three choices of meat. And then after each choice of meat, we have a choice of cheese. So we have either American, provolone, Swiss, or Munster cheese, and you can see that just by looking back up here at the menu. So our stages of our tree diagram, our first stage is a 1/2 probability, the second stage is a 1/3 probability, and the fourth stage is a 1/4, or the third stage is a 1/4 probability. So here's that tree diagram with every possible option. Now if you notice, we go down the tree to figure out our options. We have white bread with beef and Swiss cheese. So this is a white bread beef sandwich with Swiss cheese. We just follow that path through the tree. And that's how you read the tree diagrams. A wheat bread sandwich with ham and American cheese. Okay, so that's how you read the tree diagram. So now we want to assume that we can only use one choice from each column of the ingredients in the table. And then someone puts these different sandwiches in unmarked sacks on the counter. They make one of every possible sandwich. So what we want to see is what is the probability that you'll select a white bread sandwich. Well, the only thing we're asking about is the probability of white bread. Well, there's two types of bread, so that is a 1/2 probability. What's the probability that we'll select American cheese? So, how it might look on a test or a quiz, probability of American cheese. Well, there's 4 different types of cheese, and all we're asking about is the cheese. So it's a 1/4 probability. What's the probability that you'll select a white bread with ham and any type of cheese? White bread with ham and any type of cheese. So essentially all we're asking about, we don't care about the cheese, so we're asking about white bread with ham. So what we have here is we have to, since we're going down the tree, we'll look at this again. White bread with ham, going down the tree, we have to multiply those probabilities. So that is 1/2 for white bread times 1/3 for ham is 1/6. Is our probability that we get a white bread ham sandwich. What's the probability to select a sandwich with white bread that has either beef or turkey and has provolone? Well, we gotta look here, beef or turkey. So that means we're going to be picking 2 types of meat out of the 3. So here we have 1/2 because of our bread times 2 out of 3 because we get to pick 2 of the 3 meats, and 1 out of 4 because provolone is one of the 4 cheeses. So we have 1/2 times 2 over 3. Here, it's very important to remember how to multiply fractions. You multiply across the top and you multiply across the bottom. So 1 times 2 times 1 is 2. 2 times 3 times 4 is 24. So this is a 1/12 probability. And then we want to look at selecting a sandwich that has neither beef nor Munster cheese. So does it matter about the bread? The answer is no. So we can choose 2 out of 2 types of bread. We can choose 2 out of 3 types of meat because beef is only one type of meat. And we don't want beef, so we're going to take 1 away from those 3. There's 2 types of meat. And nor do we want Munster cheese, so there's 3 other cheeses that we could choose out of the 4. And again, multiplying across the top, multiplying across the bottom, we have 2 times 2 times 3 is equal to 12. And then 2 times 3 times 4 is 24, which is a 1/2 probability that we have a sandwich that does not have beef, nor does it have Munster cheese. Next little scenario, we have Katrina needing to pick a 2-person committee to accompany her each time she visits a middle school. She has 5 boys and 4 girls who have volunteered to go. So to be fair, she makes spinners with each person's name. And notice each person's name is listed exactly once. And so the first thing I want to look at is, are all the outcomes equally likely? This first question here, are all the outcomes equally likely? Well, the answer is yes, because each name is only on there once, and the space for each name is equal, or it's extremely close to equal. Everybody's name has an equal amount of space. So the second question here, what would it make the outcomes not equally likely? Well, a quick little scenario for that would be, here's a spinner with the girls' names. And you can tell that Lauren and Pam have a much greater advantage than Ave and Deb, because the amount of space of the spinner is in favor of Lauren and Pam. So this would make the outcomes, this question right here, this would make the outcomes not equally likely. The next question, what's the probability that Nathan will be selected? Explain your reasoning and list the possible outcomes for a two-person committee that include Nathan. Well, there's 5 boys, so it's a 1/5 possibility that Nathan will be selected. And here's all the possible combinations: Nathan and Deb, Nathan and Lauren, Nathan and Pam, Nathan and Ave. So questions like this basically require you to create a tree diagram. And lastly, if Ave decides she cannot go on a visit she's scheduled for, how does this change affect the probability for other boys or other girls to be selected? Well, it does not affect the boys. The boys is still 1/5. But it does affect the girls. The girls were 1/4, but that's no longer the case. Now the girls have a 1/3 possibility of being able to go. And here's how the spinner would look if Ave decides that she cannot go. These 3 sections are extremely close to being the same size. Alright, ladies and gentlemen, that's tree diagrams.